Welcome everyone to the MLOps Live webinar series, the place where we talk about bringing data science to production and seeing real business value from your Gen AI and AI initiatives. We're really happy to see all of you here with us today. We have a fantastic session coming up. My name is Idit, and I'm the head of community and open source marketing at Iguazio, acquired by McKinsey. And today we're going to be talking about implementing Gen AI in highly regulated environments. We're looking forward to having Asaf Somek, and co-founder and CEO of Iguazio, acquired by McKinsey, along with Yaron Chaviv, co-founder and CTO of Iguazio. So I'm sure you've heard this before, but it's so true, it's worth saying again. If 2023 was the year of Gen AI experimentation, 2024 is the year of Gen AI implementation. As many companies embark on this implementation journey, there is a host of challenges, especially in highly regulated industries such as financial services and telecommunication. We are lucky to have Asaf today to discuss those risks, challenges, and show us some best practices and solutions to take into consideration. Afterwards, Yaron will be discussing how to build Gen AI for production, and he'll also be showing us a really interesting demo about fine-tuning a model and adding guardrails for a banking chatbot. I won't give it away, you'll see it soon. So we're really, really happy to have them with us today. So before we begin, a few housekeeping items. This webinar will be recorded and sent to you after the webinar. There is no need to worry if you miss something, we've got you covered. As always, at the end of the webinar, we'll be taking your questions live. I know it's a super interesting part, so in order to make sure that we don't miss your questions, please use the Q&A tab on the bottom of your screen throughout the session, and we'll do our very best to get to all of them. We'll also be running 2 polls during the session, so please do take the time to fill those out. They help us make these sessions as valuable as possible for you, and we'll make sure to share the results with all of you live at the end of the session. We'd like to invite you to join our MLOps Live community, where we'll be continuing the conversation afterwards and answering any additional questions you may have. So I'm going to go ahead and put everyone on mute, and I will be recording the session so that we can send it to you right after. And without further ado, we'll get this party started. I'm really happy to invite Asaf to begin his talk.
Thank you, Dit. First, this is all about highly regulated industries, and Yaron is actually not in the office today. Yaron is actually at an event, at a global banking event in the US in Florida. So let's start with the challenges. Gen AI itself has its own challenges, but as soon as you go into highly regulated industries, it's actually much more than the usual challenges that are enough. And when we talk about challenges, it's beyond the demo stage. We've seen, and I think many of us in the industry have seen, a gazillion demos that are much easier than before to put together, given all this wonderful services coming from the cloud vendors, with basically accessing LLM through APIs, whether for RAG or for the inferencing itself. Wonderful experience to put a demo together. But when it comes to production, it's a completely different story. Hence, since the Iguazio acquisition by McKinsey, we've been super busy bridging that gap between the demo stage and production at scale, with all the challenges around Gen AI, and we'll talk about them. One challenge I would like to discuss first, which doesn't come a lot in conversation, is cost. We actually, in another event I presented at a few weeks ago, one of the largest banks in the US mentioned over there that the key challenge they have in taking Gen AI applications to production is actually cost. And we've seen it firsthand in many of our interactions with clients, that at the end of the day, after all the headaches of getting an application to be working functionally, operating to the satisfaction of the people involved, doing the right thing, getting the right accuracy, all the functional parts, then people start doing the math. When you look at the compute elements, all the infrastructure, again, whether it's in the cloud or on premises, we'll talk about that in a second, But all these compute infrastructure costs, sometimes people don't realize that they're mounting. Whether if you're using the LLM's API services, that as soon as you scale and you use them by the thousands, suddenly the cost hikes. But then when it comes to highly regulated industries, in many cases, you actually need to run the models, whether within your own cloud account, using models that you have fine-tuned or use RAG to actually enrich, or even in your on-prem environment. This is where you actually start to use directly GPUs. And this is a very expensive resource that you need to actually know how to use. And what we have seen in many cases, there is a huge gap between having a functional application and having that run at scale, because when people do the math, okay, here is a pipeline that we need to run in production, and we will need 1,000 of these per hour, then they realize that the cost associated with that is actually much higher than the business value that this application would bring. And this is where a lot of attention is needed. And the good news is that given that the industry is still yet to know how to use these compute resources efficiently, there's a lot to improve. We recently worked with the bank where we improved the cost elements of a particular pipeline by 60x, which made a huge difference between having an ROI for the application and not. So this is something that people need to pay attention to, because it's not enough to get a functional application in production. You want to make sure that you actually looked at the math of running it at scale. We'll talk a lot about GPU efficiency in a couple of slides, so we'll leave that. In terms of model risk approval, we have seen clients that are actually stuck on that. I mean, they got the technical stack, they got the architecture, they got things ready to go, but then given that they're still working in processes that are not up to date to 2024 and the high pace and all these new types of risk involving Gen AI, we see lots of projects that are stuck in that, where companies need to completely reevaluate how they're actually addressing risk. And then I touched upon it already in terms of how you actually, where do you run it? Where do you actually do your fine tuning? I mean, can you use your sensitive data with the OpenAI APIs? Most people can't. So this is, people get stuck with the question, how do I do this on-prem? How do I do this in my cloud account? And how do I build a flexible architecture that will address all of those options to have? We'll talk about that. And the last piece is around, this high pace of technology. Every other week, there's a new buzz name, a new acronym. You actually need to think of building an architecture that is future-proof. And this is actually the headline. When, focusing about a few things that I see as super important, people start their journey with like some experimentation where you actually want to build something, again, beyond the demo, something that will get you a feel of what will it take to run to production. Let's take a bank example, again, highly regulated client that for them, it was the only option was to run in their on-prem data center. It's a country where they're still not allowed to use any sensitive data in the cloud, and therefore they had to use it on-prem. But they didn't have access to GPUs. The lead times around GPU was too long, and they wanted to start the journey. We actually worked with them in a completely detached cloud environment that is actually disconnected from many kind of advanced services within that cloud environment, where we were emulating with them a full on-prem environment that is actually running in that cloud environment to basically get them ahead till they actually get GPUs, physical GPUs for the data center. So this is possible. You can actually build such an environment where you can actually start working on your use case in that cloud environment, emulating an on-prem environment using sanitized data, mimicking an environment that is actually running on-prem, but without the risk of using data, the real data. So this is something that we have done several times already with clients that waited till they received their GPUs. Fine-tuning on sensitive data. I mean, many people, we see them starting their journey with only applications that are using public data, whether it's like general policies, product information that they have, and they're doing a great job with some of these applications that are strictly using OpenAI services or other clouds. But when it comes to sensitive data, we see like a big pause there because people are yet to actually understand how to actually do the fine tuning in a reasonable way, in a continuous way with their internal data, where to do RAG, where to do fine tuning. All these questions need to be answered, so pay attention to that. And the last piece is around actually Gartner calls it composite AI. Not everything has to be LLMs. We have seen many use cases where it's a combination of LLMs and good old machine learning. Again, when you actually come to production, you actually want to reduce the time it takes for this application to run, improve your latency, and at the same time, it goes hand in hand, reducing your compute consumption. Again, whether it's CPU, whether it's GPUs, and super important to identify and build a granular pipeline where you can actually use CPUs where necessary, use GPUs where necessary, and it's not always LLMs. Combinations of machine learning, heuristics, even, God forbid, heuristics are still doable when it's applicable. So build a pipeline, use LLM when necessary, use other technologies when not. And moving to the next slide, we can actually talk more about what we see in GPUs. So, this is the NVIDIA stock over the last 2 years. More or less since a little bit more time since ChatGPT popped into our lives, 600% increase. And this is no surprise because anything you do with LLMs actually involves GPUs, whether it's GPUs that are consumed by your application at the cloud vendor environment, GPUs that you provision yourself from the cloud vendor, or GPUs that you're running in your data center. Therefore, we see this amazing performance of the NVIDIA stock over the last few years. And that comes with lots of headaches because buying today a GPU for your data center, you will have to wait a long time. You may buy like the previous generation or the previous generation, and we have seen clients settling on buying older generation GPUs just in order to get them faster than what's available out there. And I mean, the reason, again, we touched upon it already, people cannot actually take their proprietary data in many cases and just push it to the cloud services APIs. This is where they're much more careful, and this is where they need to actually do those fine tunings and the inferencing in their own environment, whether it's their cloud account, if they can do it in terms of regulatory concerns, or within their on-prem, given strict requirements. Sometimes we see clients that are self-governing themselves and imposing this restriction that sensitive data has to run in their on-prem environments. And this is sometimes also involving CapEx and OpEx concerns. Again, when you're running in your cloud environments and you're provisioning the GPUs, it's actually super expensive. And people sometimes don't feel that when they're early in their projects, and the rate of inferencing per minute per second is not that high. But as soon as this is accumulating, and you're actually provisioning many GPUs in parallel, this cost is mounting. And if you have like auto scaling, and suddenly your scale goes higher and higher, that could be a huge impact on your bill from the cloud vendor. So this is where we see a huge gap in the knowledge in the industry of how to use GPUs and how not to use them. And I actually talk about this a lot. If you look at the total consumption of GPUs right now in the world, I would argue that on average, all GPUs that are being used right now, including those that are used for mining Bitcoins, total average utilization right now would be probably less than 10%. Why? Because people are using GPUs naively. They're using them in a way that are underutilizing their resources, sometimes even by using the NVIDIA virtualization capabilities, they're still highly unutilized. And this is where I would ask you to actually dive deeper into that, get some help around that, and improve your utilization. Again, that 60x I mentioned before, it's not because geniuses solve the problem. It's because people don't really know how to use them right. And we see those gaps, and these are not multiples of dozens of X's. One other thing that we also see that between DGX systems and GPU cards that go into servers, typically the DGX systems are actually being used in larger research kind of facilities when big models are being kind of trained continuously. Most enterprises that we see actually use in their production environments servers that are plugged with GPUs. That's again from my perspective. One thing is that we see around LLMs is the different categories, and that actually calls for the processes around approving LLMs into your environment, or if you have a new application that you're building, and how do you actually treat it from risk profile perspective. This is actually a good way to look at those different categories of LLMs. For example, when you talk about models that are creating content, this is where IP concerns and IP infringement concerns could arise. But if you're talking about a model that summarizes a conversation or summarizes a document, there's less of a risk around that. So what we see best practices around companies right now that actually look at the different use cases, map the profile, and with that, based on the risk profile of each one of those use cases, know how to treat them when it comes to their processes. The next slide actually talks about how we see people building new kind of committees that provide guidelines to product owners on how to deal with risks, because you don't want one group of people to become a bottleneck when you're developing many Gen AI applications. So what we see, again, in the banking sector too, that companies are actually building kind of committees that are providing guidelines, and eventually the responsibility to adhere to the guidelines is actually sitting with the product owners that are building those applications. They have very clear guidelines in terms of if this is an application that combines summarization and creation, this is how you need to actually look at it, at the different steps of the application. And again, this is something that McKinsey, the firm, has also helped companies build those governing bodies within the organizations. The next step is around centralization. We're getting lots of these questions. So on one end, you want to innovate and you want to spread the word, you want many of your developers and your BUs to run and to develop GenAI applications. On the other end, as we noted before, there are lots of new risk associated with GenAI, and you want to govern that. So the best combination is actually to be definitely centrally oriented, but with some kind of federation when it comes to the BUs. I would look at the two options on the left, and I would pick the second one from the left, the centrally led BU executed. We can also see that this is actually, there is also a survey that McKinsey conducted recently where we see the speed to production when it comes to Gen AI in correlation with the centralization that enterprises are practicing. And the more you centralize, the higher the success is. And this is where I personally recommend the central-led BU executed when it comes to why BU execution, because you got the domain expertise within those BUs, and you want to actually leverage the development capabilities in each one of those BUs. So development, fine. But when it comes to running your production environments from the staging step all the way to production, that's where you want to centralize, both from a risk perspective. You want to run a highly governed process to understand what models you're running, what versions of model you're running, what data was used with it. Basically, MLOps practices that are applied to Gen AI. And with those new risk profiles that we didn't have before. We didn't think IP infringement risk would be something in the governance of machine learning in the past, but suddenly with Gen AI, this is definitely something that we should be aware of. So governance is one sense, and when it comes to risk associated, this is one example, the IP. But then cost, again, if you actually run centrally, you can actually combine resources and serve multiple applications in parallel on all those expensive resources. Again, GPUs can run many, many models in parallel when you're talking about smaller models, or you want to run use multiple GPUs to run in large models in a distributed way. You can actually build this kind of an environment, leading into the factory story that we'll get to in a second, where you imagine a central factory where you run all of those applications in parallel on shared set of infrastructure that can scale up and down. This is how you'll be most cost effective and also risk preventive. And that leads us to the factory concept. We work closely with clients to actually implement this approach, where it's a continuous process. We've seen that in classic machine learning, and it's no different in Gen AI. Only with Gen AI, it's a little bit more complex because you have some models that are running in your environment, some models where you will actually leverage the APIs from the cloud vendor, given that all the data is external, and that would make sense more from financial perspective. You want to govern all these processes from the data stages through the development of the models and the pipelines, fine-tuning processes, linking that with the right data set. EU AI Act is actually in effect very soon. You want to have all these capabilities to be able to adhere to the regulations. And then comes deployment. We talked about you need to know what LLMs are running in production right now. If something pops up and suddenly or you hear that some LLMs are dangerous for organization, you want to actually be able to immediately react to that. I've seen some clients recently that said, we have some applications that are running in production. We're completely federated. We don't really know what's running. That is super dangerous. I mean, if something is happening there, some hallucination, how do you protect yourself? And then comes the last piece. How do you actually improve the accuracy? How do you actually know when to retrain? This is where comes what we call live ops, when it comes to monitoring the performance of the model, of the applications and the models within them, monitoring the data quality that keeps actually being fed into these models. This is a continuous 24/7 operation that if you want to scale Gen AI, you need to actually put in place.
Thanks, Asaf. What we're going to look into a couple of minutes, very interesting demo of how we add the guardrails dynamically and automatically into a model. But first, we need to understand that there are a bunch of risks that need to be addressed in every Gen AI application, whether these are hallucinations or privacy violations or toxicity and so on. And next, so we really need to think about how to address those. And also when we build something, we don't just want to build a prototype, we want to productize, and that requires pipelines and data engineering. It requires testing, required monitoring, and also a feedback loop that we're going to focus on today, how we can take the monitoring data and further improve the model in order to address the risks and improve the accuracy. Next. So, and we talk about guardrails, they have to be applied on many different places, whether it's in the data processing stage. We have to curate the data and make sure it's clean, it's accurate before we index it in a vector database or before we use it for tuning. In the testing phase, we want to verify that our model is accurate and behaves appropriately. In the application pipeline, we can do it. And also in the monitoring, we can collect all the information from production and meter the application, as we'll see in a minute, and also use the same data for further improvement of the model. Next. So what you can see here, again, a generalized stack. We have the data management part of ingesting the data. We have the test and development part of testing that our prompts are properly configured. The model may need to be tuned, evaluate, making sure the application is doing what it's supposed to. And then when it is ready, we can do deployment through a rolling upgrade process in the usual CI/CD flow. We have the application pipeline where we get the request, we do prompt engineering, enrichment, use an LLM, one or more, and do the post-processing, and finally, again, the monitoring. Next. What we're going to see is what you see here in the diagram. In a second, I'll go over a notebook and demonstrate that. So we have an application. There's a bot, a chat that calls the application with a standard stack using LangChain, deployed as a Nucleo microservice function, a serverless microservice function. The Nucleo function calls the LLM server, in this case, based on open source LLM. Now, all the calls to the LLM and back are being recorded using the MLRun monitoring service, which also has a plugin for evaluating LLMs, as you'll see. We're actually going to see how it's being implemented. All the data goes to two places. One is a Grafana dashboard that shows the evaluation, tells us how the model is doing, but also the same data is getting logged into a data lake, into Parquet files, and could be used later to further fix the model by running in a application ML pipeline, registering the new model, and rolling upgrade the LLM server to essentially, think about it, you're going to eventually fix the model, address all the guardrails, increase accuracy over time. Instead of decaying the performance and accuracy, you're actually improving the application over time. So with that, let's move to a demo. In this demo, we see how we add guardrails and evaluate a banking chatbot using model monitoring and continuous fine-tuning techniques. This way we can increase the robustness and reduce risks from our application. The architecture is such that you have a client. This client is talking to a chatbot application with its application logic using LangChain. The application uses an LLM server that hosts an open source fine-tuned model. So there's a query and reply to that model. All those queries and replies are being logged into a Kafka stream, and from there to the LLM monitoring and evaluation framework in MLRun using a plugin that we'll see. All the data is stored from the logging and monitoring is stored in a object storage and used later on to fine-tune the model, the LLM model. There is a ML pipeline that takes the data from the monitoring, does some additional data processing, the LLM fine-tuning to generate the fine-tuned model, test and evaluate so we verify that the model is actually good, and then storing that newly tuned model in the model registry in MLRun. Once the model is stored, we can do a rolling upgrade and update the LLM server with the improved model with better guardrails, less risk, better accuracy, and that will immediately impact the application performance. In this demo, we're not going to do it fully automated and scheduled. We're going to do it interactively with some simple changes. Everything can be moved in MLRun to be fully automated. What you could see here is we're going to use a technique called LLM as a judge to use one LLM, in this case OpenAI GPT-4, to evaluate the results of our open source LLM model, which is tuned for this specific banking application. So the first thing we need to do is we generate an MLRun project, we enable the monitoring, we're building the evaluation function, which evaluates the results of the LLM or our chat application. In order to build the evaluation function, we have some data set that we created that shows what's a good banking question or a not good banking question. We're just going to use that as a reference to test our evaluation function. Then we build the evaluation function using, again, this technique called LLM as a judge. We build a prompt. The prompt is evaluating the question and the answer and telling us if the answer fits a banking application. Like if you're asking for something in the supermarket or asking to who's the president, it's not a banking application. So that will essentially say that this is not a banking application response. So it was essentially not guardrailed. So we build this evaluator. We want to see that the evaluator actually works. So we take the test data set and we see that the evaluator actually correctly saw which was a banking question, a banking answer, and which wasn't. Now we want to take this evaluator that we built and leverage MLRun's ability to build evaluation or monitoring plugins. So I can essentially build my own monitoring function for drift, accuracy, hallucinations, and whatever other application I want, and plug it in the MLRun model monitoring so it builds dashboards, it generates data sets, and could be used for fine-tuning, and so on. So this is where we're just setting a model monitoring function and deploying it. This essentially generates a serverless function which will be used for monitoring the model. Then we deploy a model server. In MLRun, you can deploy a LLM server using some Hugging Face models. In this case, the Google Gemma 2B. It takes GPUs, it auto scales, it's very fast, very high performance. So we can, again, deploy that model. And now we have a running endpoint of this model serving function. Now, what we're going to do next, we're going to just send a bunch of questions to the endpoint of the model and see if it really responds well or not. This will be used for us to monitor, to look at the monitoring dashboard to see how is the model behaving in terms of risk. So right now we use the model which does not have the guardrails. So again, we're running all of this, and if I'm opening the Grafana dashboard for the model monitoring, what you can see, because there are no guardrails and I ask questions which are not banking, I get very bad results, a lot of failure on the guardrails. So what we will need to do now is take the data set that was generated, and based on that data set, we will tune the data set from the evaluation, will fine-tune the model. Before, let's just see the chat in action. So you can see that it's really doesn't have the guardrails here. Okay, now we can see the fine-tuning process. We're taking the data set that was generated from the evaluation, running an mrun training function. We won't run a full pipeline, but again, to build an automated scheduled pipeline in mrun, it's really simple. You see, we're training the model. We have a newly generated model that we're going to now deploy. And now using mrun, we'll do a rolling upgrade for the LLM server. Again, just putting the new version of the model and running deploy. This will substitute the old version of the LLM server with the new version, and our application will immediately work with that. There's no need to change anything. And again, this could all be automated as part of an automated and scheduled pipeline. And once we have this new one, then we can run the same questions we had before and see that the model monitoring actually shows us now that most of the questions have passed, everything is good. And again, if we'll run it again and again and again, we're going to move from 80% to 95 or even more accuracy, and we could even add more and more guardrails to essentially improve the application. Let's see the same thing in action in the chat for a second. Good. So what we've seen is, how we took a baseline application, we added evaluation, so now we know exactly if we are having risks or not, and we fixed it by continuously improving the model over time. So, it's actually getting better and better and better. So thank you. With that, we finished the demo and we can move to the questions, I believe.
Let's dive into the Q&A. So the first question is, can you provide examples of guardrails other than prompt engineering?
Yeah, so I can, again, prompt engineering was something called LLM as a judge. So it's not really prompt engineering, it's comparing the results. But you can have different other guardrails like measuring toxicity. Is the language toxic? You can put a filter that measures the toxicity. You could look for bias. For example, is the answer or the response biased towards a certain population, man, a woman, and so on. You could do other guardrails that look for data privacy by putting a model or some regular expression and checking if there are any phone numbers, social security numbers, private data, and so on. You could measure for hallucinations and so on. So there are different guardrails that you can apply, or different monitoring. You've seen that everything here is pluggable. So you can just build your own monitor. And so she takes the question, take the answer, run some comparison with whatever logic you want. Also could be third-party libraries that exist, and then just respond, and it will all get recorded into the system, to the dashboards, to go into the data lake for further tuning.
Thank you so much, Yaron. So another question, which either of you can answer, is focusing more on hallucinations. So I guess from a technical perspective, Yaron, is this something, can this demo monitor hallucinations? And then Asaf, if you want to talk about in general, do businesses see this as a big challenge when implementing Gen AI in production?
Maybe we start on the business side. Of course, I mean, we've seen all these examples with the airline that invented the chatbot, invented the policy that eventually the airline had to adhere to it and pay stuff that they didn't really intend to.
Air Canada, I believe, yeah.
Yeah, but why name Yeah, this is public information. There was a car dealership in the US that the customer managed to trick the chatbot to sell a car for $1. And they're mounting examples. I don't know if you've heard the stories on McDonald's recently, but I mean, these are um, it's a combination of hallucinations and basically models that are being manipulated, and in some cases, bad accuracy. Yaron, how do you deal with that?
Yeah, so again, very application specific. Some hallucinations could be solved exactly with this mechanism of sort of LLM as a judge to verify that the answer meets the question. There are challenges where it comes to knowledge accuracy, like is the bot really replying with the right knowledge? So in reg applications, there are ways to do it, but essentially comparing the document content in the vector database with the response and making sure that the response doesn't go out of the content that is in the document. You have those techniques. For things around numeric values, I've also spoken here. I'm at the digital banking conference with several clients. Is usually you won't just go to a database, to an LLM. What you need to do is build a tool that goes into a database and searches the database and get a very concise response, not like look up in documents or in ChatGPT, and then respond with a real value. And you can validate that the value that was generated was actually coming from the structured data and not invented by the LLM. You just let the LLM summarize the values that were generated by the database and not bring content from its own model.
Yeah, Yaron, you bring a point that, I've seen it in several conversations where not everything has to be a question that goes into an LLM where you actually dig for the information in there. In many cases, you have a sequence of interactions with an LLM that eventually triggers an action. And that action could be, querying a database for a precise answer of something that is very deterministic rather than, taking the risk and doing it through an LLM. Again, more expensive. And there is also always the risk that it will be something that you didn't intend to.
Yeah, someone just gave me an example at the conference. They want to scan financial documents and get numeric value of certain, financial values for a bunch of stocks. So you could go and have like ChatGPT go scan a bunch of filings and so on. That will be very expensive. But you could do something else. You could take the documents, extract numeric values into a database table. Then when you see it's a question about, stock prices across time, etc., you search it in the database. You don't go to megabytes of documents and starting to search. It's inefficient. It's not economical. It's very slow, and it will probably hallucinate far more than just translating the natural language to a query, running a database query and responding.
Yeah, I heard it in one of the conversation, people, with, Gen AI as a hammer, everything looks like a nail.
Yep.
So people are overthinking about using LLMs everywhere. I mean, again, it comes with a lot of consequences. Wherever you can actually avoid it, and if the result is good enough in terms of accuracy, I would still be using like traditional methods.
Yeah, or the combination again, just let the LLM turn the result into something natural and native. But the data itself can come from curated sources.
Indeed.
So we got two questions, which is related to what you guys just spoke about monitoring. So why in general is it important to monitor an LLM and when you should implement monitoring?
I can take first, always, like depending if you want to play some games with LLMs or you want to go to production. So if you want to go to production, don't you want to know if you're risking your business and like suddenly the LLM doesn't function, or you're generating bias or toxic language or hallucinating and so on? You must know that, so you don't find it for your clients complaining about your application that sort of is not generating a good enough result. So you want to monitor first in real time, be able to understand over time what's the performance of the application. You want to also log all the information, just like we use it for fine tuning. You could also use the logs for just figuring out what's going on, what kind of questions are being asked, what kind of answers are being supplied, passing it through human examinators to see that it actually makes sense. Or you could just risk and just play it safe and expect for it to blow. That's another approach in life.
And maybe just to add, there are several levels of monitoring when it comes to governance. I mean, Ron just talked about the functional side of what the LLM is doing. Again, going back to the conversation I mentioned before, some people don't even know what LLMs are actually their organization is using right now. And they need to know that. That's why we're again promoting this centralized AI factory approach, where in all your production applications what models are being used right now, what versions of these models, because at any given moment, maybe the provider of that model, again, whether it's a commercial provider, whether it's an open source one, where something is detected, you would want to know that, okay, there's a risk now just by running this version of the model. Let's stop the application that uses it to avoid the risk. Just like, the story with Log4j, which is a different kind of example, but at the time, there was vulnerability that was exposed without the CI/CD frameworks and the governance frameworks of software applications. People wouldn't have known where is this package being used in our organization. So it's very similar here. Models could be malicious, and we will see that, sadly, that's the nature of things. And over time, people will realize that this version of a model, there is a malicious part. Stop using that version till you get an upgrade, till you get an alternative. And this is how people will be managing their applications.
Yeah, pretty much like you're getting patches today to your mobile, every couple of weeks. So, also models will get security patches. But in addition to measuring the application side, there's also metering and monitoring the resources. You want to know, the GPU consumption, CPU, memory, not only this consumption, but like who's using it, Is it this department or the other department? Which application uses which resources? Maybe you find that there's an application uses lots of resources, but it has very little value to the business, or the other way around. So you want to essentially monitor as many aspects as possible.
Yeah, so this is a third dimension we're talking about when it comes to monitoring.
Yep.
Thank you so much, Yaron and Asaf. I want to invite you all to log onto our website, www.iguazio.com/MLOps. There are a lot of previous sessions of the MLOps Live webinar. This is our 30th session. So we have 29 other sessions, and tomorrow the 30th session will be up there as well for you guys to browse through and take a look at your convenience. There are a lot of blogs, best practices, case studies, and more resources for you. So feel free to check that out and let us know what you think. If you have any questions, feel free to reach out to me. At this point, I said it before, but I just want to take another moment and thank you both so much for this really valuable session, your fantastic presentations, and that really great demo. The recording will be up and live and sent to you all tomorrow. And thank you for your great questions and engagement in the chat. We really appreciate all of you joining us today. And we look forward to seeing you at our next session next month. So stay tuned, and thank you all so much for joining today. Bye, everyone.
Thank you, everyone. And I hope we didn't scare anybody too much, but you should be aware of all these risks associated with Gen AI. It's a cool technology that should be treated, accordingly.
Knowledge is power, Asaf. So bye, everyone.
Bye.